Okay, so last section we're going to look at in Chapter 7 is 7.6. As I said, we'll spend 2 days on it. We've done this type of stuff before in 7.3. In 7.3, we did more of a graphic kind of solve method. This is going to involve more algebra. So some things that are going to come up are quadratic formula, factoring, that ASTC diagram, which we can go over again if we need to, and we're going to use some identities. Mostly Pythagorean, but there are a few others. Okay, so if any of the identities that come up that you don't know as we do them, I would put them on your reference sheet for the test on Friday. Okay, so some different techniques that we're going to use to try to solve these problems. Quadratic formula and factoring I already mentioned. This one I didn't mention. Rewrite your problem using a single trig function. Okay, so what do I mean by that? Well, that problem on the right does not have a single function in it. It has some cosine and it has some sine functions. That's going to be hard to solve. Okay, you don't want to have two different trig functions in the same equation. Okay, so we're going to rewrite it with just one trig function. So let's try the first one. 2 cosine squared x plus sine x plus 1 equals 0. Okay, I've given you a hint in brackets down below at what identity you're going to need to use in this problem. So kind of another general hint. When you have multiple trig functions, and you want to get rid of one, the one you always want to get rid of is the one that is squared. So when you have multiple trig functions, always substitute for the squared one. Leave the one that's not squared alone. Don't touch that one. Okay, so when you have multiple trig functions, always substitute for the squared one, or the one raised to the second power. Okay, so what trig function here is raised to the second power? Cosine. So that means we are going to substitute in something for that. Okay, so let's rewrite that equation and let's just leave room to plug something in. Everything that's not in the red box is going to stay exactly the same. So you're going to have 2. Leave parentheses to fill in something. Plus sine x plus 1 equals 0. Now, you have to figure out what are you plugging in for the thing that's squared. Usually you're going to go back to a Pythagorean identity and use that. Okay. So we have all our Pythagorean identities. Oh, I must have I closed them, I think. Well, you guys wrote them all down before. So we're going to use this one. Sine squared plus cosine squared equals 1. And which one do we have to get by itself? Cosine squared. Yep. So if you get cosine squared by itself in that identity, what would it equal?
Negative sine squared.
Can you say it again just without...
1 minus sine squared.
Yeah, well, we'll just say it as 1 minus sine squared. So So cosine squared is 1 minus sine squared. Any question how we got that? Now, that is what's going to get substituted in right there. So instead of writing cosine squared, you're going to substitute in 1 minus sine squared. And it doesn't really matter what letter they use. If they use x, then you just use x for the whole problem. If they use a theta, use theta. Just a variable. Okay, so now we have a 2 in front of the parentheses. What property do you think we need to do with the 2?
Distribute.
Yep, we need to distribute it up. So let's do that. 2 times 1 gives me 2. And what's 2 times negative sine squared? Negative 2 sine squared. Yep. Everything else stays the same. Now, I might have done something else at the same time in that step, because I can see some like terms. We can deal with them now. We just have to write the whole thing again. But what are my like terms on the left-hand side?
2, 1.
Positive 2 and positive 1. So when those combine together, what do I get? Positive 3. Okay, everything else stays the same. Okay. Now, that equation is very similar to this one. So let me write, like in Algebra 1, what something like that would look like. It would look like this. That's basically what we're kind of solving. What kind of equation is that? It's a quadratic, exactly. So that's exactly what we're going to do to solve this problem. We're going to treat it just like it's a quadratic. And one method that we can use to solve a quadratic is to factor it. So that's what we're going to try. If factoring doesn't work, what's the other thing you can use?
Quadratic formula.
You can use quadratic formula. Yep. Okay. Now, one thing is when you are factoring, you generally don't like something like that. You don't want the squared term to have a negative in front, because that's going to mess up everything you know about factoring. So what could I do to get rid of that negative? I don't care if there's negatives anywhere else, just not there. Yep.
Take a negative 1 on the outside and put the sign of all the numbers on the inside.
Yeah, so you could basically like divide everything by -1. Just change the sign of all the numbers. So it's going to be 2 sine squared x minus sine x minus 3 equals 0. Which off to the side is basically like solving this. Okay, so the one in black is what we're really solving. But if you can do the one in red, then you can do the one in black. All right, if we're going to try to factor that, well, we got to get it equal to 0, but it already is. What's the first thing you put down on the left side if you're going to factor something? This step doesn't even involve numbers. Yep.
Brackets, negative, brackets, plus, like the...
Yeah, you need your parentheses, like that. Is that what you meant?
Yeah.
Yep. All right, so we'll do the one in red, and then we'll apply it to the one in black. What would be your first term in each set of parentheses? You need an x, yep, and
2x.
a 2x. Now you have a negative in the middle and a negative at the end. So what would your symbols be inside here? You would need a plus and a minus, and it does matter which one you put where. Let's try plus and minus. If it's wrong, we can always just switch it. Okay, now I need two numbers that multiply to give me 3.
1 and 3.
So I would try 1 and 3 and see what happens. Okay. 2x times x is 2x squared. What's 2x times 1? 2x. What's x times negative 3?
Negative 3.
And what's 2x minus 3x? Negative x. Perfect. So that's how you want to factor it. Now, let's apply that to this one. Instead of having an x, you have sine x. So we're going to write exactly the same thing. Just don't write x. Write sine x. So what's going to be in my first parenthesis?
Two sines.
Anything else? Yeah, the whole parenthesis. There's still more that needs to go inside that first one. Minus 3. And the second parenthesis? Sin x. Yep. And plus 1. That's how you factor what's in black. And you can check it. 2 sin x times sin x is 2 sine squared. 2 sin x times 1 is 2 sin x. Sin x times negative 3. And 2 sin x, take away 3 sin x, is negative 1 sin x. Yep. And negative 3 times 1 is negative 3. Perfect.
So it's just that one, but we put sine.
Yeah. Yep. We want to get used to maybe not having to do that step on paper all the time. But if you have to do it, at first you can do it. All right. Now, once you have your factors and it's equal to 0, what do you do with each factor? You set them equal to 0. So we do exactly the same thing. Take each factor and set the first one equal to 0. And set the second one equal to 0. Okay. Now, what would be your first step to start to get the 2 sin x by itself? Yep. So always deal with the addition or subtraction first. So add the 3 to the other side. Something else I can still get rid of on the left.
Divide by 2.
It's exactly the same thing you would do right here. Add the 3 and then divide by the 2. 2. Now this is the problem you had in the homework last night. Some problems in the homework tonight are going to start you at this step right here. So they're basically starting you at the end of the problem. They'll have done all the work right up to this step. All you have to do is now get rid of sine. What do you do on each side to get rid of sine? Yep, take the inverse sine. And this was the last question in the homework I gave you. So take the inverse sine of what's on the left. Take the inverse sine of what's on the right. And now let's type it in. So second inverse sine, 3/2. Okay. When we press enter, we're going to get an error. What is 3/2? Like as a decimal. 1.5. How high does the sine function normally go? Only goes to 1. It doesn't go to 1.5. So that's why just in this case, the number comes out too big, which means this part of the problem has no solution. Okay. Let's just look at the other part. First thing we have to do is put that 1 on the other side. How would you move the 1 over? Subtract it. Yep. And now, you could do inverse sine of both sides, but it's easier to just think of the graph of sine. That's the graph of sine. 0, 90, 180, 270, full cycle is 360. Where does the graph hit -1? Right there. Whenever this is equal to a 1, a -1, or a 0, those three are easy to do without inverse sine because it's the highest, the lowest, or right in the middle. So that's 270. And that's the only answer to that question. Normally there would have been some other answers, but in this case the other ones didn't work. What's 270 the same as in radians? If you know what 90 is, just think of it as 90 with a 3 in front of it, times 3.
Oh, so 3 pi divided by 2.
3 pi divided by 2. Because pi divided by 2 is 90, and then you're tripling it to get 270.
If you were to get sine x equals 0, which one would it be then? Because would it be the 9?
Be 2 of them.
180? Or
Yep,
oh,
this-
it'd be both? Okay.
This one,
Yeah.
and this.
It would, okay, then it wouldn't be the 360.
It would not be the 360 because if you go back up and look at what they said,
Oh, right.
did they say to include or not include the 360?
Not
Not include. So that would be like this. Not including the 360. Okay. So any questions on that one? Technically, we should write the answer that way, 3 pi over 2, because they did say they wanted radians up there. All right, so let's try another one of those. So find all solutions again. We're going to do 0 to 2 pi. But I always do it in degrees first. Because if there's a nice answer, you'll be able to see it in degrees. And then you can manually convert to radians. Okay, so this one has an extra step. In the last problem, what was it already equal to for us?
0.
It was already equal to 0. This one isn't. So what we want to do is get it equal to 0 first. How can I get it equal to 0?
Subtract 1 plus cosine x.
Sure. Yep, you could subtract the 1 plus cosine x. So I'm going to subtract the 1, and I'm going to subtract the cosine x. And that's the only extra step to this problem. What's on the right side now once you subtract that? 0. That's gone. That's gone. Now on the left side, you get 2 sine squared x minus cosine x. And since we know this is going to be kind of like a quadratic, you always put the number at the end. Minus 1. So it's similar to the last one, except instead of a plus 1, it's a minus 1. Instead of a cosine squared, it's a sine squared, but you're still going to do it exactly the same way. Okay, so first thing, we have 2 different trig functions. Which one are we going to substitute for? Yes, always substitute for the trig function that is squared. Okay, always substitute for the squared one. Okay, now we need to figure out what sine squared is. Okay, if you want, I mean, you can write, you can get ready for it. Leave room for what you're going to fill in. Copy everything else down. Okay, so now we need to figure out what sine squared is. And my hint is to use the same Pythagorean identity we did before. Except don't solve for cosine squared this time. Do sine squared. So what is sine squared?
1 minus cosine squared.
Yes. So we're going to fill in 1 minus cosine squared. And then what's the next property we need to use? Yep. We need to use distributive. Okay. 2 times 1 gives me 2. And then 2 times negative cosine squared. Negative 2 cosine squared. Everything else stays the same. Now, when I do this step, I usually combine the constant I get from distributing with the constant at the end. I do that at the same time. We didn't, so now we got to do it. The constant is 2 and a minus 1. What do you get when you combine those together? 1. 1. Yep. So now we got to write that down. Negative 2 cosine squared minus cosine x, and then 2 minus 1 is 1. Okay. So now this is basically like a quadratic equation. What's the method we used last time to solve the quadratic?
Factoring.
Yep, factoring. And if you're going to factor, you don't want the number that's with the squared term to be negative. So what can I do to fix having a negative?
Divide everything by negative 1.
Yep, divide everything by negative 1. You don't always have to divide by negative 1. Sometimes it doesn't come out that that's a negative. But so far it has. All right, now we're ready to try to factor. If you get stuck, because it looks confusing, think of it as factoring this. That might look less confusing to some people, and it's exactly the same thing. Okay. So what's going to have to be my first term in each parenthesis?
First one is 2 cosine squared. 2 cosine x.
So we're going to need a 2 cosine x. Yep.
And the next one is cosine x.
And a cosine x. Okay, that's just like a 2x and an x. Yep. Cosine x. That's right. Okay, what about the signs this time? Both positive, both negative, or one of each?
Positive, 1 positive, 1 negative.
1 positive, 1 negative. And it does matter which one you put where. I would maybe try it like that. If you're wrong, you can always just switch it. And now we need 2 numbers that multiply to give us 1.
1 and 1.
Just 1 and 1. Right. Let's see if we got it. So 2 cosine x times cosine x is 2 cosine squared. What's 2 cosine x times 1? 2 cosine x. What's cosine x times negative 1?
That'd be negative cosine x.
Negative cosine x. And what's 2 cosine x? Take away 1 cosine x.
Cosine x.
Just cosine x. That's exactly what we wanted. So we factored it correctly. All right. Now, what do we do with each factor? Set them equal to 0. Okay, so 2 cosine x. Sometimes what I start to do is I rearrange this at the same time. I won't do that. I'll just copy the whole thing and set it equal to 0. And then we'll start to rearrange. Okay, so we need to move the negative 1 and the 2 to the other side. How do we move the negative 1? Add it. And how do you move the 2? Divide. So what's going to be on the other side when we add the 1 and divide by 2? 1/2. Now, that's the problem, like very similar to a problem you had in the homework last night. Now you need to get rid of cosine. What do you do on each side to get rid of cosine? Yep, the arc cosine or inverse cosine. Now, before I write that, look at what we have. Cosine x equals 1/2. What kind of number is 1/2? Positive. Okay, so let's think about that for a second. We're looking for where cosine comes out positive. There's always 2 places. Yep, here and here. 1 and 4. So we'll have to remember there's a formula for quadrant 4 we're going to need in a minute. Okay, we don't need it yet, but keep that in mind. All right, so take the inverse cosine on each side. Inverse cosine and regular cosine cancel. And now we have to take the inverse cosine of 0.5. Okay, so let's go here. Okay. Inverse cosine of 0.5 gives me 60 degrees. Now I'm supposed to get it in radians. I'm not worried about radians. I can do that at the end. Okay, that's an easy part. I'm just worried about figuring out my answers first. So I got 60 degrees. And we all agreed the second answer is supposed to be right here. Once you get the angle that's here, what do you do with the first quadrant angle to get the answer down here? 360 minus the angle. So the other answer is 360 minus 60, which is 300. Now, if you want both of them in radians, that's pi over 3. And what do you multiply 60 by to change it to 300? What is that? 5. So the other answer is 5 pi over 3. You don't have to use that shortcut if it's confusing. You can go back to the way we learned at the beginning. Multiply by pi and divide by 1/8. But that's what's going to happen. All right. Any questions on the answers we got from that part? All right. Now, cosine x plus 1 equals 0. For that one, I just think about the graph. Whenever this involves 1, negative 1s, or 0s, we're going to think about the graph. How do you move that plus 1 to the other side? Subtract. So we're going to be looking for where cosine equals what number? Negative 1. Okay, now think of your graph of cosine. Looks like this. 0, 90, 180, 270, 360. Where does cosine hit negative 1? Where does it? 180. Yep, 180. Exactly. And 180 degrees would be equal to what in radians? Pi. Yep. So this one had 3 answers. Pi, pi over 3, 5 pi over 3. Doesn't matter what order you write the answers in, as long as you write all 3. On Edulastic, most likely would be set up just, I'd say, like put commas between your answers. But you could have them in any order. Okay, any question on that one? There's a lot going on here. So It takes a couple days to kind of get good at it. Yeah.
So how did you know what says the one on the left has two answers while the one on the right only has one?
Because when you look at where cosine hits -1, draw a horizontal line at -1. How many times does the horizontal line hit the graph? Just once. 0.5, that's the first one we did. Where was cosine equal to 0.5? 0.5, well, if this is 1 up here, 0.5 is here. How many times does it hit 0.5? Twice at those two spots. So if the graph, if you're looking for where it hits anything except 1 and -1, it always hits twice. If it's exactly 1 or exactly -1, it just hits once. Yeah.
Can you scroll up for just a second?
Okay, so let me just kind of explain something too. Okay. This is pretty much the longest kind of problem you have. They start you off with an equation that's not even equal to 0. The next shortest problem you could have is they already set it equal to 0 for you. Doesn't save you that much time. The next problem that they could give you that would be a little bit easier is they've already taken care of writing it with all one trig function for you. Okay, that would be one level even easier than what we did. Okay. Another level easier than that is they factor it for you. So they start you at this step. And then one level, like even easier, they take each factor and they already set them equal to 0 for you. Okay. That's pretty much almost the easiest kind of problem. Okay, because they start you at this step. I guess the only easier thing would be is if they didn't give you two things equal to 0 and they just gave you one thing and you just have to solve it. That was like the last question in the homework on Monday. Okay, so we're doing all the hardest version. I'm starting you from like scratch and showing you every step. But you're not going to have to do every step in every problem. Okay, let's try this one. Okay, so we're solving where tangent x equals 3 cosine x. All the problems we've dealt with so far had what trig functions in them? Sine and cosine. That's what I would do first. I would make sure that we have all sines and cosines. So what's on the right is okay. What's on the left is not. We had a formula for tangent. Does anybody remember?
Yes. This would be
Right. Tangent is sine over cosine. That's not a Pythagorean identity. It's in the same section, but it was one of the easier ones. Tangent is sine over cosine. Now, it doesn't look like anything is squared here. But my hint is that when you do the next step, you're going to end up with something squared. So what do you think we could do on both sides that would eliminate this fraction? We don't want to have a fraction. We've never had a fraction before. No fraction there. There's no fraction there. So I don't want to have a fraction. Yeah?
Multiply by cosine.
Right. Multiply both sides by cosine. When you multiply by cosine and divide by cosine, they cancel each other out. And then don't forget to do it on the other side. Okay. So what's on the left side now? Sine x. And what's on the right side?
4 cosine x. 3 cosine squared x.
Yes. Now, this question, where you have a trig function on one side and then one on the other side squared, is pretty much like this one. You have a trig function, and then you have one on the other side squared. It's pretty much the same thing. Okay. So what do we want to get this equal to?
0.
Yep. We want to get it equal to 0. So what should we move?
Sine x.
Nah, cosine squared.
You want to move the cosine squared?
No, do sine x. That way the 3 cosine squared x.
I like having the 0 on the right side, you know?
You could flip
Let's
it.
put the 0 on the right side. You'll see why. I do think it's better to move cosine squared. Watch what happens. So let's put this on the other side. What's 3 cosine squared minus 3 cosine squared? So that's gone. Now, you might be thinking, well, wait a minute, you just made the cosine squared negative. I thought we didn't want to have a negative in front of it. You're not going to have a negative in front of it, because watch what happens. It's negative right now.
Oh, yeah.
Okay? So, what do we have to do at this step?
We gotta
Divide by
we gotta substitute
Yeah, which one do we want to substitute for?
the left for 1 for sine.
So the cosine squared.
The cosine squared.
Yeah.
And we did that earlier. Let's go back to what cosine squared is.
1 minus sine squared.
It's 1 negative and then sine squared. Okay, so watch what happens when you substitute that in. Okay, so what did we just say we're filling in for cosine squared?
1 minus sine squared.
1 minus sine squared. What about sine x? Keep it? And what about the equals 0? Keep it the same. Now, what do you have to do with this negative 3?
Distribute.
Right. What's negative 3 times 1? Negative 3. I'm just going to put that over here because I like to put the number all the way on the right. And what's negative 3 times negative sine squared? Positive. So by moving that to the other side, you temporarily made it negative, but then it ended up becoming positive on its own. Okay, so 3 sine squared, and the plus sine x stays right where it is. Okay. Any question up to that step? All right. Now, let's write that the way you'd see it in Algebra 1. If you tried to factor that one, okay, you might try like 3x and x. And then you realize, well, your signs have to be one of each because that's a negative. So you could try like a plus and a minus. And you need 2 numbers that multiply to give you 3. So you could try a 1 and a 3. But no matter how you do it, you could switch the 1 and the 3. You could switch the signs. It's never going to quite work. So this is not factorable. So what can we do when it's not factorable? Right. We do quadratic formula. Now, if you did quadratic formula with the one on the left, what would you be trying to find? Right, I'm sorry, the one on the right. What's in black? What are you trying to find? Well, you got to write down the ABC, you fill it all in, and then that gives you the answer to X. Okay, maybe a little bit more general. It gives you the answer to whatever is sitting right in the middle, which normally when you do a quadratic, it's an X. When we do quadratic formula on this one, it's going to give us the answer to what's sitting in the middle. So the idea is here, you take your answers to the quadratic formula and you set them equal to X, and you're done. Here, you take your answers to the quadratic formula and you set them equal to sine X. Okay? That's the only difference. This is X equals quadratic formula. This is sine X equals quadratic formula. Okay? Quadratic formula always solves for what's in the middle. But the steps in the quadratic formula are exactly the same. It's just what you set it equal to at the very end. So what's A? It's the same in both. A is 3. Yep, what's B? 1. And what's C?
Negative 3.
-3. Okay, so let's fill those into the quadratic formula. So negative b plus or minus what comes next? Square root of b squared, yep. And then after that,
Minus 4ac.
4 times a times c. Okay, and divided by
2a.
2a. Okay, so now we figure out what that comes out to. We're going to be using a calculator, but it's going to be a lot easier if we can just simplify all that, so we don't have to type all that in. Okay, we're going to be subtracting a negative number. So what's going to end up happening? That's going to turn into addition. So I might as well just make it addition now. Okay. What's 4 times 3 times 3? 36 plus 1. Okay. Now, if you were doing quadratic formula, you'd be done. You just say x equals, and those would be your two answers. What are we supposed to put on this side? Sine x equals. Yep.
That's all we have to do.
So let's write that. Well, we got to get x, right? You got to get the number for x. Right now, we don't have x by itself. This means you have two different answers. Right? So you have sine x equals the positive in the top, and sine x equals the negative. You don't have to write it as two separate things, but I think it'll be easier to look at rather than using that symbol. Okay, so here's one. And there's the second one. Okay, now how do we get rid of sine? What is it? Yep, arc sine or inverse sine. Yep, you're just going to put all that in the calculator. And then take the inverse sine of what's on the right. Right, so I'm going to do it in degrees and then see what we get. Okay, I'm just going to type in this part first. Negative 1 plus the square root of 37. And then divided by 2. So remember what you had on the left. You had sine x. And now I just typed in all this stuff.
You divide it by 2.
Oh. Thank you. Divide by 6. What kind of number is this?
Decimal.
It's a decimal. How about thinking of something else? Because what I'm starting to think about is this. Right. What kind of number is it? It's positive. 0.847. So we're going to be taking the inverse sine of 0.847. Where are the two places where sine is positive? The top two. Okay. So let's do the inverse sine. And I already know what negative 1 plus root 37 over 6 is. I just did it. It's 0.847. So I can just do the inverse sine of the last answer that was on the screen. 57, it's about 57.9. We'll just call it 57.9. No matter how you do it, you're not going to get a nice answer. So it's about 57.9. What's the other quadrant that we were looking for an answer in? Second one. What's the formula in the second one once you have 57.9? Yep, minus it from 180. Okay, so 122.1. Any question on what we did there? Now, let's do the same thing again. But watch what happens this time. It's going to end up being a little bit easier. what do you do to get x by itself and get rid of sine? It's exactly the same thing you did there. So x is the inverse sine of that. Before you type that in, the inverse sine, just type in this part. Because I want to know if it's equal to like a positive or a negative number. Let's see what happens. So negative 1 minus square root 37 divided by 6. Okay, so what kind of number is that? Negative. So where is sine equal to a negative number? Yeah, you would expect the answers down here. But look at this number, negative 1.18. How low does the sine function normally go?
-1.
That's below negative 1. So,
No solution.
right, when we try to type that in, type in the inverse sine of the last answer that I had on the screen. It gives me an error because it doesn't go that low. So this time you don't get any answers from this part. These are your only two answers. Yep, those are the only two. Okay, so we're gonna practice. You know, we'll spend quite a bit of time on the homework tomorrow, and then we'll practice more in class. Okay, that's not the whole.
That's not the one. So it's like all the equating stuff, and then it's like just make it like because sine x squared plus cosine x squared equals 1, and you can change it. So you don't have like sine. Well, you see, like in the problem, it says sine squared x. It says sine squared x. You can be
Okay,
like, oh, well,
that's fine.
typically it's when it's sine, one of the factors.